the Retro Hack Shack knows.
Almost 20 years ago, I visited Paris for just one day. One of the many things I packed into that day was a trip through the Paris Catacombs. These catacombs are well worth a visit if you go to Paris. Apparently, these old limestone quarries were used as burial grounds in the 18th century when the city was growing so fast they didn't have room to bury their dead. I always thought it would be cool to reconstruct a wall of skulls for Halloween, but that can get pretty expensive. However, I recently came across this Instructable showing how to make replica skulls out of milk jugs. I'll put a link in the description below. I love the idea of reusing old plastic to make something new instead of throwing it in the garbage. So today I'm going to show you this process, and of course, I'll add some technology to the mix to make these skulls even more creepy. I started by buying one of these Resin Skull models. Don't buy a plastic skull. Since we're going to be using hot air here to melt plastic, I needed something that can withstand high temperatures. I'll also put links to this type of skull and other materials I used in the description as well. Next, I cut a hole in the bottom of the skull so I could attach it to a PVC pipe. This is important because the pipe holds the skull in the air so you can work around it more easily. Then I used some epoxy to attach a PVC fitting to the hole I drilled out. Once that was dry, I mounted it onto a length of PVC pipe and attached it to my work surface. I cut the handle and the screw top off of a 1-gallon plastic milk jug made of HDPE, or high density polyethylene plastic. That's important because that type of plastic is highly recyclable, easily reworked, and safer to work with than other forms of plastic. You can already see that the shape of this jug is already kind of similar to the shape of a skull. I used a hot air gun in a rotating motion to slowly soften the plastic until it became a little clearer. Then I pressed down on the plastic to mold it onto the skull. Notice that I'm wearing heavy leather gloves. This is important as you can definitely burn yourself without proper protection. It took me a few tries to get the process down, so if you try this yourself, be sure to take your time. My second skull came out twice as good as the first and took half the time. Try not to burn the plastic. You want the plastic to get a little clear but not change to a brown color. I also found that making a slit in the back of the plastic jug helped me make a tighter fit because I could overlap the plastic in the back where no one else would see. Also, it helps to get the skull off of the mold when you're done. Here you can see how much better the second skull looks compared to the first. I ended up taking the lower jaw off the skull because it was pretty hard to mold the plastic around that part, and I think it looks a bit more authentic that way. Then I used some hot glue on the part that I cut in the back just to keep everything together. This black hot glue actually binds a lot better to plastic parts than the normal glue gun sticks. Now it was time to paint. I'm using 3 different colors here to get the final look: ivory or off-white, black, and a flat tan. I used a slightly different method than the Instructable here. The Instructable only sprayed ivory paint on the inside of the skull, but I thought it looked better when I sprayed both the inside and outside of the skull with a few coats of paint. But that meant I had to change the type of paint I used for the next 2 layers. Since the ivory was an oil-based spray paint, I needed to use water-based paint for the next few layers that I could wipe off without taking off the ivory base. You'll see what I mean in a minute. After letting the ivory paint dry for a day or so, I found some black and light brown paint in my collection of old house paints. I used the black paint to fill in the eyes and nose and make some lines where the plastic had deformed in places. Then I wiped off any excess with water. Once this had dried, I made a light wash with the brown paint. I wasn't sure about this next part because the Instructable said to paint the skulls with the brown wash and dab it dry with a damp cloth, but to my surprise that process actually worked really well and gave the skulls a weathered look that they didn't have before. I want to put some LEDs in the eye sockets to give the skulls a creepy vibe. So I found a drill bit that was slightly smaller than the size of the LEDs I was going to use. Then I drilled holes in the eye sockets, being careful to keep my fingers out of the way at the back of the plastic where I was drilling. With that done, you can already see that it looks like these skulls have tiny eyeballs left in them. It sort of reminded me of the skull mask Johnny's gang wore in Karate Kid.
Johnny, leave him alone, man. He's had enough. Homicide, but he's had enough, man.
With the skulls done, it was time to move on to the electronics. Okay, so for this project, I'm going to be using an Arduino Nano, or actually an Arduino Nano clone. You can see they're quite cheap. If you want to support Arduino, I highly recommend that you buy an Arduino branded Nano if you want to follow along with this project. But if you're cheap like me, you can get one that's quite a bit cheaper here. So you can see that this one is just $2.99 on eBay. Again, this is a clone, but the project is open source, and so people picked up the project and made cheaper boards. But any of these Nanos, whether you get the real one or the clone, they should work fine. The other thing we're going to need for this project is our PL9823, which is a programmable LED. And the way that works is there's a data in pin. There's 4 pins: a data in pin, a voltage pin, a ground pin, and a data out pin. So the way these work is you string them together. So you have the first one, the data to make the LED do whatever it's going to do comes in, and then it goes out through the data out pin and goes to the next LED and goes in there, tells that LED what to do, and then goes to the data out. And you can have hundreds of these things strung together in close proximity. In fact, I built a LED cube made entirely out of these programmable LEDs, and it does all sorts of interesting things. And then they all share a common voltage. In this case, these are 5-volt LEDs. They're 5-volt tolerant. You don't have to add a resistor. And they share a common ground, of course. If you're going to be doing a project where you're stringing hundreds of these together, then obviously you have to worry about making sure that you don't go too far from your voltage source and your ground. You wouldn't just want to string them in a big long chain, for example. You'd probably want some commonalities between them. But in this case, we're only going to have a few LEDs, so we don't have to worry about that too much. And if you try to order these, you'll see that there's different sizes. The F8 and F5 refer to the width of the LEDs. This is an 8mm LED. The other one's a 5mm, more common, probably that you're used to seeing in electronics, 5mm LED. And there's different names for these. There's WS8212B and just all kinds of them. Pixel, NeoPixels from Adafruit are the same kind of programmable LED. So you can find these all over, but these are the ones that I just happen to have on hand, and they'll work fine for this project. Now over here, let's take a look at the code and what's actually going on here. You can see it's a fairly short script. I like to keep this easy for new beginners, if you will, that are new to programming, so really easy to use. I found this online, this code snippet, and I would love to give credit where credit is due, but I can't find where I found this anymore. So if this is your code, or if you think this is your code, let me know, because I have changed some things, and I'll be sure to give you credit in the description. Anyway, we're using a library here called Fast LED, and this is specifically built for programmable LEDs like this. It's probably overkill. We don't necessarily need to use it, but it does work very well. It manages the timing to go to each LED so that things work correctly. It's a great library. I use it in a lot of different projects, so I highly recommend it. And you can see here that we're defining the pin that we're using as the data pin. This is called LED pin. That's the data pin on the Nano, pin 3. The number of LEDs here, we're actually only going to have, we're not going to have 250. We're going to have, 4 of these for now. Eventually I'll have more, but I'll just put 4 for now. The color order, depending on your choice of programmable LED, sometimes the first element is red, the second is green, the third is blue. Sometimes it's green, red, blue. They can vary. And then, of course, we specified the type of LED, and this matters because the timing changes from programmable LED to programmable LED. So if you don't specify the right LED type, you might get some wonky behavior there. I also added this definition up here so that we can specify what color we want the LED to be. And then I copied down here, if you're going to be taking this code, by the way, is available on the website, retrohackshack.com, or will be shortly after I publish the video. So you can go download it there. But you see, I have the simple HTML referenceable colors in here that you can pick from. And I've added them all here with their equivalent hex value for that color. Like if you were doing a website, you would use these colors, but you can also refer to them with these common names to make it easier. So I'm going to be using the color purple. And then this ramp time parameter I added, which is the how fast the effect is going to be. This is going to be a little bit of a strobe effect, but I want it to be a slow strobe effect. So it should take 3.5 seconds in this case to turn the LED fully on, and then another 3.5 seconds to turn it off. It should give us a nice spooky effect. I also changed some of this script to make it so that the brightness here, the max brightness, actually works. It didn't work in the original script, so I had to change a few things. But you can set that because different colors, your eye works differently with different colors. So you may find that you want it brighter or not as bright, or maybe it's in a location that's has more ambient light, or maybe it's in complete darkness, in which case you probably want to take the brightness down a bit. So I'm going to leave that at 100. And in the setup here, it actually just declares the LEDs here, what they are, based on all of these variables we put up here, and then sets them to one color. And then in the loop down here, it's pretty simple. It uses I don't understand exactly the math here. Maybe you do. But it uses that ramp time that I mentioned before, and iterates this value breadth as it goes through the loop. It iterates it up and down and up and down. And then it just assigns that brightness. We've already set the color, so it just assigns a brightness level and then shows it, and then goes back again and sets a brightness level, shows it, sets a brightness level, shows it, and you'll see the effect when we go through when we hook up the LEDs. You'll see the effect that it has, and it's kind of a breathing effect, which should be really nice for Halloween. So that's the code. Now let's go ahead and install the LEDs into the skulls. Okay, so I'm back at the bench and got my two little friends here, you can see, with their eyes cut out, ready to go. I'm trying to figure out how to attach these. Essentially, we've got 4 LEDs, and it can be difficult to know which side is which. So I showed you the pinout. It's important to know that there is a flat side to these. At least these LEDs have a flat side, and that flat side is data out. So now that I know that this flat side is data out, I know that the order always goes data in, 3 volt, ground, data out. And I've just got to keep that in mind when I'm connecting my wires. I also was trying to figure out how I'm going to connect all of these, because like I said, they all have to be connected to power and ground. And then the data in on the first one goes to the data out, and that goes to the data in on the second one. So I've got to run, since there's 4, at least since I have 2 skulls right now, there's 4 eyes. So that means I have to run 4 power and 4 ground, all back to either the power source, or in this case, I'm just going to run them to the Arduino, because there's not too much power going through here, so I don't have to worry about running too much power through the Arduino Nano. So I think what I'm going to do for this particular instance, I wouldn't do this if I had 5 or 10 of these, but since I only have 2 for right now, I'm just going to use these little, I don't even know what they're called, but they just make a connection so that everything is connected together. So I'll do one of these for ground and one of these for power. That means I'll have a spot for each of the 4 wires for ground and power, and then the last one will come out and go back to the Arduino Nano. It's just a temporary solution. If I was doing a stack of 5 or 10 or 15 of these, I would probably come up with a different, more elegant solution. I might make my own PCB. In the past, I've used USB cables to do this, or RJ11 cables, which you could do. You could even use a Varil board like this, where you have a strip board where you could hook everything up to one strip of this. That might be ground, and then maybe skip a few, and then do another one that's all 5 volts. and just run everything back to that home run situation, they call it. But in this case, I think I'm just going to use a couple of these connectors here to connect all the ground together, another one to connect all the power together, and then just run long cables to connect the data in and the data out, and that should do it. Now for powering this outside, I think I will just run, and I don't have one here to pull up for you, but I think I will just use a USB power bank. If I want to put this out in the grass or outside somewhere for a few hours, I could just use a USB power bank and run this all off of that all night. And that's probably the typical thing you're going to do, because it's not like you're going to run this every night. The other idea, though, if you wanted to make this more permanent, in terms of power, you could use one of these batteries, these 18650 batteries or something similar, in a little pack like this, and then that would give you nominal 3.7 volts, although the voltage is going to vary between 4.2 and 3.3 volts as the power runs out of the battery. And then you could hook that up to a boost converter, or in this case I have a little boost converter / charger. You could hook the battery up to this and then hook this up to your project, and that would run it for a while, and then you could just recharge it whenever you wanted to. But in this case, I think I'll just use the USB power pack, because this is kind of a one-shot deal, at least certainly for this year. And I can always pull it out next year and hook up my battery pack again, and away I go. I probably won't be using this more than once a year, I wouldn't think. But that's something you could do. And I'll be talking more about this solution in another project that I'm working on, where I do use this board and this battery in that project. So we'll get to that in another episode. Okay, well, now that everything's soldered together, I just want to go ahead and connect using these little connectors here. Connect all of the power together, and then I'll hook up the data line and we'll see if this is going to work. Okay, so I've got my Arduino hooked up to my benchtop power supply, and we'll just hook the 5 volts up to 5 volts, ground up to ground. Now you notice that they come on a lot of, these programmable LEDs work differently. So, sometimes they will, when you don't have any data, they will light up, and sometimes they won't. It just depends on the model. I've noticed that these tend to light up blue when you just hook up power and no signal. The other the NeoPixels sometimes do not. They don't light up at all. So it just depends on what model of programmable LED you have. Okay, so let's hook this up to digital pin 3, which I think is this one. Nope. This one. Yep. There we go. And now you can see this is the effect that we programmed. So they're kind of breathing in and out very spookily, like very slow and very spookily. And those will be the eyes of the skeletons. So everything's working. And now we can insert them into the eyes of the skeletons. Okay, here goes one. Should just be able to press kind of hard, and it should just go right in there. I don't know if you'll be able to see this when I do it. My hand, I'm sure, is in the way. But it did go in. Now I'm going to do the second one. There we go. One down, one to go. And these will sit like this, and all of these cables and whatnot will all hide underneath the skeletons. So let's plug it in, see what it looks like. Wow, that looks really cool, actually. I don't know if you'll be able to see, but when those are outside, that's going to look really spooky. Very neat. Well, that's going to wrap it up for this edition, this spooky edition of Retro Hack Shack Halloween 2020. So even if you can't go out and, trick or treat this year, or maybe your kids can't go out, find a fun project that they can help you with. Or if you don't have kids, find a fun project for yourself. Maybe like one where you make a few of these skulls, or there's all sorts of fun Halloween projects out there you can do. And then maybe incorporate some things like some blinky lights or some sound. Make it fun, make it exciting, and have a good time anyway. Eat some candy, regardless of whether you can go out and go trick-or-treating. I know it's a bummer, but make it fun anyway for you and your family. And I hope you like this episode. Go out and make some skulls. I never thought I'd be saying that in my lifetime, but go out and make some skulls and have a good time. Thanks for watching. Please subscribe. Hit that like button if you like episodes or want to see more like this. And support me on Patreon. If you go to Patreon and you can get in touch with me directly, you can vote on upcoming episodes, and you can get your name in the credits. So support me there. Thanks for watching, and we'll see you next time.